Hi boys and girls, welcome back to the 3rd and 4th grade science club. You're here again in Miss Sylvie's home, and I'm glad to see you, or you to see me through YouTube, however this is working. Anyway, I miss you guys. I hope you're doing well. We're gonna start talking today about geothermal energy. And so these last 4 weeks, we're kind of talking about different alternative energy resources that we have. And oil and gas, we're very dependent on oil and gas in our world, really. You know, cars, they run on oil and gas. Our homes are powered by oil and gas. And oil and gas companies are going, we can't do this forever. So what are some other resources that we might be able to use? I just talked to a woman this week at our church, and I asked her about her husband's job, just checking in, see how they're doing. And she said, well, you know, he works in oil and gas, but technically he's working at finding alternative resources. So he works for an oil and gas company, and his job is looking at alternative ways to produce energy. And that's kind of what we've been talking about. We talked about tidal energy, and that's not oil and gas, right? That's just looking at the tides of the ocean. And we talked about wind energy, and that's just using wind that's in the air. These are renewable resources. And so today we're going to talk about another one. It sounds really complicated, but it's not. It's really not complicated. And we'll talk through it, and I think you're going to see that this is something that you've heard of and seen before. So we're talking about geothermal energy. Okay, geo means earth. Thermal means heat. So earth heat is basically what the word means. So here's our vocabulary word. Go ahead and pause the program and write down your vocabulary word in the back of your lab notebook. Okay, so just like the word geo, earth, thermal heat, this word means heat energy made and stored in the earth. So the definition is kind of built right into the word. Isn't that cool? I think that's really cool. Geothermal energy, heat energy made and stored in the earth. So in our earth, it is hot. It's really hot. And that's why, you think of volcano and you think of lava spewing out, right? That lava is hot. So the further you go into the earth, the hotter it gets. The greater the temperature, the further you go down into the earth. And so scientists are looking at ways that they can use that heat that's already in there. I don't know if you've heard of Old Faithful. It's a geyser that's in, I believe it's Yellowstone. Sorry, my eyes. I think it's in Yellowstone. Is it in Yellowstone? Mr. Sylvie gives me a nod. He thinks so too. And Old Faithful is there, and it's a geyser, and it just shoots steam up in the air every so often. You may have heard of Hot Springs. So there's a place, Hot Springs, Arkansas. The whole town is named Hot Springs. And that's the heat from the earth heats up the water that's there, and it happens naturally. And so it's naturally heated water from the earth. And so scientists go, I think we can use that to make energy. So the whole thing we want to do is make a turbine spin. That is the ultimate goal, because if you can make a turbine spin, you can use wires and magnet, and you can create electricity. And so what can we do to get this heat from the earth to spin a turbine? That's what they're really looking at. And so we have this little diagram here. So go ahead and it might be on a 2-page thing for you. Go ahead and cut it out and glue it into your lab notebook. Go ahead and pause the program to do that. Okay, let's talk through this diagram. I'm gonna set it down here on the table like that. Okay, here we go. So I'm gonna read through the steps. The first thing that happens is they pump hot water. So this is a pump. They pump the hot water from the earth, okay? So this would be an area where there's naturally hot water. So like in a hot springs kind of place. And so they pump this hot water up, and as it's coming, it's with a high pressure. As it's coming up, when the water reaches the surface, the pressure drops, and it causes the water to turn into steam, okay? So then you can see it says steam right here at number 2. And so then the steam goes this way. And if you have steam, right, you can have something that spins a turbine. So the turbine is there. The steam spins a turbine, number 3, which is connected to a generator. And remember, these are just wires and magnets, a generator that produces electricity. And so then it shows electricity coming here. And then what they do is that steam continues this way. It goes to a cooling tower, and then the water goes back down into the earth to be reheated and to come back up through the process. So energy is created naturally from the earth, and then we return it and let the earth make the energy to create the movement of the turbine to create electricity. Isn't that a cool thing? I think this is super cool that scientists have figured out how to use the energy of the earth, the heat energy of the earth, to create, this is mechanical energy, movement, right? And then this movement, mechanical energy, is then converted into electrical energy. So I just think this is a really cool thing. Now it's a little tricky because you have to find places in the earth that have naturally heated water, but there are some. And so this might not be a primary resource that we're able to use, but in areas, in homes and businesses around where hot springs are located, or these vent pockets are located, they might be able to just power those homes. And I think that would be an amazing thing for them to be able to do. Isn't that cool? So let's go ahead and talk about our Bible verse now that we have a little better idea of what earth, thermal, heat, earth heat, geothermal energy is, okay? So I'm gonna go ahead and put this to the side, and let's get out our Bible verse, which was attached to that page. And you're gonna cut it out like that. Shoop. Shoop. Little sound effects. And go ahead and pause the program. Were you trying to catch my tongue sticking out? I stick my tongue out when I cut things. This is something I have learned doing these YouTubes about myself. So go ahead and pause the program and glue this into your lab notebook. Okay, let's read it together. In the 600th year of Noah's life, yes, he was very old, on the 17th day of the 2nd month. On that day, all the springs of the great deep burst forth, and the floodgates of the heavens were opened. Okay, so this is about Noah and the ark, right? And God said he was going to send a big flood on the earth. And so he said, hey, Noah, make an ark. And this is the very beginning. And we see that there's water underneath the earth. It says on that day, the day that the flood started, on that day, all of the springs, so that's water, of the great deep, water in the earth, burst forth, and the floodgates of the heavens were opened. So we see not only does water come from above, it also came from below. And some scientists, Christian creationist scientists, believe that all the continents were together in something called Pangea. And on this day, the continents split. And if you take my 5th grade science class, we spend a little bit talking about that as well, Pangea. And so the springs of the great deep burst forth. And so the earth had to burst as well, right? And the floodgates of the heavens were opened. So what does this have to do with geothermal energy? Well, we've been talking about the water that's in the earth, right? And how it's very hot in the earth. And that we can use the energy of that hot water to spin turbines, to create mechanical energy, which then can turn around and create electrical energy. And so this shows us that God very much knows about this, that he made this, and that he used this energy also during the flood. So our God is an awesome God. The Bible is 100% true, and there is science all over it, cover to cover. so you can trust the Bible. And scientists are just now catching up to the things that are in the Bible. Isn't that cool? All right. So let's go ahead and move into an experiment that I have for geothermal energy. Okay, so you have this page right here. So go ahead and let's cut them in half. I think yours are together. So go ahead and cut them, split them apart. And let's go ahead and work through this one right here. It says geothermal energy. Problem. How can we model how geothermal plants work? Materials, a pot, a hot plate. So if I was at school, I would use a hot plate, but since I'm here at home, I'm just gonna use my stove. So a pot, a hot plate, and a pinwheel. And a pinwheel looks like this. Remember we made pinwheels out of paper? Well, this one I got, this is Slinky brand. Anyway, you can get them at the dollar store. I think maybe I got this at the dollar store. I don't know. But you know what I like is it's an American flag and it was made in the USA. Isn't that very appropriate that something that has the American flag on it would also be made in the USA? I think so. All right, so this is a pinwheel and they're fun. And I had this in my front yard and then I was like, you know, I'm gonna bring it in for this experiment. So anyway, okay. I've been putting weird things in like windows and writing things with chalk and just for the kids, the neighborhood. Anyway, let's think about the children. Okay, so that's our pinwheel. Procedures. Your teacher will boil water in a pot. 2, your teacher will place the pinwheel over the can. Now I'm confused. It doesn't say can over here, over the pot. Count how many rotations the pinwheel spins in a minute. Repeat 2 more times. Hypothesis. If we place a pinwheel over a pot of boiling water, then the pinwheel will spin blank times. So how long? For 1 minute. Okay, so I'm gonna have to use Mr. Sylvie's phone for my 1 minute countdown. And then we will count how many times it spins in 1 minute, and then we'll repeat 2 more times. So let's do the first thing, and that's our hypothesis. So if we place a pinwheel over a pot of boiling water, then the pinwheel will spin blank times. Go ahead and pause the program to think about how long, and then write down how many times you think it'll spin in 1 minute. All right, let's get started. So we're gonna go over to our stove in our kitchen. And I think we'll just, you know what, I have a timer here. Let's see. Okay, I'm gonna just test it. Yeah, I think this will work. And then I'm gonna set a little timer here for 1 minute. Ready, set, go. Oh, what happened? There we go. I have to find the spot too. Slow, right? Okay, I think I'm gonna start the timer over now that I know where to do it. Okay, ready, set, go. Okay, that's 1. That's 2. That's 3. That's 4. That's 5. That's 6. That's 7. That's 8. 9. 10. 11. 12. 13, 14, 15, 16. Okay, so for our first trial, it went around 16 times. So go ahead and write that down on your data table. 16 times for our first trial. Excuse me. Okay, all right, just a little tip. So I'm gonna set it again for another minute. Ready, set, go. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that time we only got 12. And maybe it's because I have less water. I don't know. Okay, so go ahead and pause the program and write down 12 for trial number 2. Okay, let's get started with trial number 3. Are you guys ready? I'm gonna let it get there and then timer, ready, set, go. Okay, I don't know. Okay, 1. Okay. Am I too close? Too far? 2. 's being really stubborn now, huh? 3. 'Okay, that time we only got 3. That's really weird, right? Maybe the position of it moved. All right, write down 3. I think that 3 is an outlier, right? Like that one is kind of a weird number, I think. Go ahead and write down 3 for your 3rd trial. Okay, so let me come back to my page. And I don't have colored pencils, but we'll work on this. Okay. All right, so trial number 1 was, do you remember, was it 16? 16 and then 12 and then 3, I believe that's right, yes? Okay. And then we're gonna go ahead and graph these. I'm looking here, I don't understand why this is there. Okay, I'm gonna fix this on y'all's. So this will be over this part here. So we're gonna make a bar graph. And let's go ahead and make, do we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, let's make each one of these worth 2. So each box is worth 2. So I'm gonna write these on the side. 4, 6, 8, 10, 12, 14, 16, 18. That will cover us. So look, I want you to make sure that this number is coming off of this line, okay? So that what you're saying is that this whole box is worth 2. These whole boxes are worth 4 to that line. Does that make sense? So make sure you're coming off of there. Now, this is always 0. The corner is 0 because if you have no box, you have 0. So this is making a bar graph. So we're gonna start by numbering the sides. The first line is 0, the second line is 2, this line is 4, this line is 6, and I'm just counting by 2s. 2, 4, 6, 8. And then keep it coming up all the way. And then let's do up to 18. We only have 16 as our highest number, but that way we're definitely covered, okay? And I'm gonna move on your sheet, I'm gonna move this over so that this 1 is over this box, okay, instead of a line. And so our first trial, we're gonna color this all the way up to the 16 line. We're going to color this whole part right here. And so what that says visually, if anyone looks, they're going to be able to look and they're going to go, oh, look at that bar. How many turns did they have? Oh, they had 16 turns. So it's a very easy way for them to be able to see that. And I'm going to move this 2 on your page over here, okay? And we're going to go ahead and color up to the trial 2 up to the 12 line. We got to make sure it's over this. See, that's the 2 there. I'm going to go over that one. And we're going to color this whole bar up to the 12. So anyone looking at it can see that there was 12 spins on trial 2. Trial 3, sad trial 3. So move the 3 here. This is where yours is going to be. Now, you might go, oh, but we counted by 2s, and this is a 3. What are we going to do? We're going to cut this little square in half. Okay, so 2, 4, we want half, which is 3, and that's going to be okay. And visually, someone can see, oh, it didn't go all the way up to the 4, so it's not 4, but it's not 2, so it has to be 3 spins. Okay. And we didn't get into half spins or anything like that. We just got into whole spins, so that's good. Okay, so that's how we see a bar graph, and you can see, just looking at it, oh, our first trial was a lot, medium, and then very little. You can just see right at an instant. Isn't that cool with bar graphs? Miss Sylvie loves graphs. It's true, I do very much love graphs. Sometimes I read information, lots of data, and I go, let me see if I can find a graph that has this information, because I like graphs. Okay, before we move on to our next activity, I want us to go ahead and make a scientific drawing about what we had on there. So I want you to pause the program and do your scientific drawing of our lab setup, okay? All right, so I'm gonna draw mine. This is my burner, and then I'm gonna draw the pot, right? I'm drawing upside down. And then I'm gonna draw bubbly water, and then steam, yeah. And then I'm gonna draw, forgive my pinwheel. This is my pinwheel, and then I'm gonna show that it was spinning, okay? And so to label this, I would label this. I'm gonna flip this around so that maybe Mr. Sylvie and I can split the difference. Pinwheel, and I'm gonna label this steam, and I'm gonna label this pot, and then I'm gonna label this boiling water, and I'm gonna label this heat source. So that's going to be my scientific drawing, so that if someone were to look at this, they would know, oh, that's how y'all did that. Oh, that's really cool. Or if you like keep this notebook forever and you're like telling your children about a class you took long ago, and you were like in quarantine, but you still did your schoolwork, and you did this, you watched your teacher do a science experiment, and like, oh, here, let me show you in my lab notebook. You can show them your drawing. That would be super cool, don't you think? That would be a really cool thing. Okay, so that is our geothermal energy model. And I'm also gonna change this. You're not gonna have this on yours. Place the pinwheel over this is gonna say pot, because can doesn't make any sense. There's no cans. I will fix that on yours too. Okie dokie. All right, the next thing we're going to do is a little engineering challenge. Now, some of your moms may have stuff for you and some of them may not. I'm gonna do it both ways and we're gonna just test it out, okay? Just hang with me, you'll see. So, geothermal energy engineering challenge. So, have this page. How can we keep the water warm by using paper or by using foil? Okay. And so I have a couple little pans here just to catch any drips that might happen. And I have 2 cups. I'm going to do it both ways. I'm going to do it with foil and with newspaper, 2 different ways so that we can see which way is better. I also have saran wrap and rubber bands to kind of trap in the water so it doesn't get too messy. The pan's here to catch drips that might happen, but we want to keep them as dry as possible. So I have saran wrap and rubber bands for that. And I have a thermometer. If you don't have a thermometer, that's okay. I'm going to take temperatures of both, so we're going to see which one is better. But what you can do, if you're doing this at home, you can design your own using aluminum foil, or I just have white paper, but you could use newspaper also, or you can use like scrap paper. I don't know if you guys have a scrap paper pile. You can use scrap paper too, okay? So this is what we're gonna do. We're gonna imagine and plan. So with hot water in there, with paper and with foil, or both, what would we like to do? I'm gonna come up with my plan to do here, and you guys can come up with your plan about how we're going to trap heat in this cup using paper or foil, okay? Let's design. All right, so I'm gonna have a cup here. Oh, let me help my cameraman. I'm gonna turn sideways and draw sideways. There we go, does that work? I'm gonna have a cup here, and of course a cup here. And I think I think the heat's gonna mostly come out the top. So I think I'm gonna do balls. I'm gonna use balls like that. And I'll do them along the sides too. My first instinct says to make a pyramid, but we almost need to like protect this area more than the sides. So I think this is what I'm gonna do. I'm gonna do balls. I'm gonna do it for both of them. Now, some students in the past have just wrapped the paper and the foil around, and that's an option too, but I think I'm gonna make balls for that. All right, so let's go ahead and get this done. My hot water, I'm just gonna, that boiling water that's in the pot, I'm gonna use that water because I put it off to the side so it's not boiling. And I'm gonna fill my cups with that. So let's go ahead and head back over there to fill up our cups. All right, got a ladle. Now, the most scientific thing to do is to make sure I have the same amount of hot water in each, which means I need to use, oh, this burner is hot. You can just use like really hot water from your sink if you want to. And I think we're gonna do, oh good, I have metric system on the side. We're gonna do 150 milliliters of hot water in both. Mine actually have a really cool little line right there. You could do that too. We just want to make sure that they're even. They don't have to be exactly even. I mean, Miss Sylvie's doing exactly even, but you just don't want it to be like you have hardly any in one and then one in the other. It's just not fair, right? Why is it hotter? Is it hotter because you had more water there or what? I don't need any of that stuff. Okay, we're gonna go back. All right, now what we're gonna do is we're gonna cover them with this. This is just so that things kind of stay a little dry. And I want to put stuff on top too. And then let's do this. This is my paper one. Oh, in my drawing, I didn't think this through. In my drawing, I just thought I'd go like down the sides, but it's a 3D object, right? There's a front and a back too, not just the sides. Whoopsie. Whoopsie. So it is kind of a pyramid kind of looking thing, huh? Newspapers work really well for this too. If you have newspapers or like old grocery ads, you know, those are always good too. Oh, I'm all like trying to bunch it in and I think I just made it worse. Okay, all right, all right. Yeah. Stay. All right, aluminum foil tape. Now, you can try both. Usually with my students in my class, I say you can choose one, and they choose whether they think paper is better or aluminum foil is better. Sylvia is watching me very, trying to figure out what I'm doing here, huh? Okay, let's see. Yeah? Does that seem fair? I don't know, we'll see. We'll see what happens. Okay, we're gonna leave this. We're gonna go outside and check on our compost and just kind of pause on this. So, I have our compost outside and you need this page and it should be glued into your lab notebook. So you need this page. Go ahead and pull that out. And I'm gonna go ahead, I'm actually gonna dump the compost out so we can really look at it very closely. Okay, all right, let's head out and take a look at our compost. It's a really pretty day. Well, there's a wasp right over here. All right, Mr. Wasp. Oh, here's my thermometer. Let's go ahead and get our thermometer in our compost. Did we lose all of our bugs? I think so. I think we're bug-free. Yay! Let's go ahead and put our thermometer in and get our temperature for our compost. What a pretty day. Okay, can our cameraman see it okay? Just gonna zoom in there. Oh, we need the little lines though, right? Let's see. I'm gonna turn it just a little bit like that. Okay, so that looks like 20, oh, is it dropping? It's dropping, huh? It's dropping, huh? 20, I think we'll go with 27. It's 26.5, but we're gonna round up. 27 degrees Celsius. Is it still going down? No. You know what? I don't know what's happening. What's happening here? It's dropping. Oh, we just should be patient probably, huh? Okay. We'll go with 26 degrees Celsius. 26 degrees Celsius, and that's final. Okay. All right. Good sciencing, guys. All right. So I'm going to go ahead and actually show you what happened to all of our compost in here. Okay. So let's see what broke down and what did not. Come on out. Come on out. There we go. Is that all of it? Yeah. All right, so, ooh, it's a little slimy. So we can see, ooh, look at this. This is our avocado peel. It's like crunchy. And I'm gonna have to wash my hands after this, aren't I? This is this the cardboard we stuck in there? I told you I was gonna stick some cardboard in there. Maybe not, it's a little gooey. This is our banana peel. It's breaking down really nice, right? It almost just looks like dirt. This is orange peel. Now our leaves and our grass did not break down very much, but our food waste, our fruits and vegetable food waste, broke down pretty nicely. And it just looks like really great, rich soil. So all of those nutrients are going back into the soil. Wow, this looks really good. What's this here? A little nervous. I think this is more avocado peel because it's like really hard and kind of crunchy and crumbly. And then this looks like, oh, grapefruit. That's right. Mr. Sylvie had grapefruit. So there's grapefruit peel in there. It's still a little gunky. I think what I'm going to do is, I just bought some new pots for plants. I'm going to put this just in the bottom of the pot. And I bet it will continue to break down. But I'll never know because I'm not going to go dig it back up. Once I put all my beautiful flowers in there, I'm not going to dig it back up. But I'll just put this in the bottom of our pot. But this is compost, y'all. Well, I think it needs a little longer. We gave it, what, we've been doing this for like 3 weeks? 3 weeks. And so we've given it 3 weeks to break down. And it doesn't smell bad. You would think, oh, it would be so stinky. But really in trash, what stinks is your like dairy and your meat. That's the stuff that makes your trash really stinky. But really this is, I mean, it's a little moldy, you know, like, I don't know if you guys did this at home. I'm curious to see. Feel free. Oh, look, here's a stick. It's still a stick, very much a stick. And the leaves are still very much leaves. And these are oak leaves, and we got to get them out of our yard because they're constantly falling, and then they prevent the water from getting down into the grass, and so then our grass doesn't grow very well. So it's kind of a constant battle with that. I don't even know what that is. All right, I will be washing my hands, but I thought this was very interesting. Look at that. I think this is the cardboard. Yeah, this is the cardboard I stuck in there. And if you look, it's starting to break down. It's definitely wet and slippery. I could rip it all up and it would, probably continue to break down more. But I was just curious to see, I think it would break down. It's a plant product, right? It's from a tree, from paper. And so I think over time the cardboard would break down. And me ripping it up probably helps. Okay. All right. Ooh, bless you, Mr. Sylvie. Okay, very cool. Very interesting. Okay, so let's go ahead and answer these questions. How did your compost column change over time? So go ahead and pause the program and write your answer for that one. Okay, so what I would say is the leaves and grass did not change very much. But the banana, the peels, the fruit and vegetable peels started to break down into soil. Okay, number 2, why did it change? Go ahead and pause the program to answer that question. Okay, I would say that they're decomposing. That everything breaks down and they are breaking down and turning back into earth, right? Okay, number 3. How does this help us in conservation? Go ahead and pause the program to answer this question. Okay, for this one, this helps us to know that our trash doesn't all have to go to the landfill, that we can use plant fruits and vegetable waste, food waste, and we can use it to create really nice soil. So that helps us with conservation. Okay, number 4. if you were going to do this experiment again, what would you do differently? What else would you want to test? Go ahead and pause the program to answer that question. Okay, what I would say is I would like to put in different kinds of leaves. I would like to know, like, we have a crepe myrtle. I would like to know if those leaves would break down faster than the oak leaves, because oak leaves are kind of thick. So I wonder about that. Kind of surprised about this grass. What else? Well, what would I do differently? That would be what I would do differently. I would like to try different leaves and see if they would break down faster. But I don't know if they would because of the grass. See, I have questions, and that's good. Science is about asking questions and trying to answer those questions. And so you're never really done because you always have more questions to ask. And I have more questions. But this looks like really great soil. Oh, we put coffee grounds in here too, right? Does not smell like coffee. Okay, all right, that will go in our planters. And maybe add nutrients to the soil. Okay, so let's go ahead and, while we're out here, make sure, this is glued in your notebook, okay. While we're out here, I wanna show you guys, do you remember we did the tundra? We did shallow root growing, and we put pinto beans in like a small Tupperware, and we wanted to see what would happen to the roots. And we noticed the roots went horizontally like they do in the tundra, because the tundra, there's only 1 inch of soil. The rest is permafrost, permanently frozen ground. And so we did this in class. We even looked at it in class. And then I was like, I don't know what I'm gonna do with these. Well, I brought them home and my kids were like, you should just plant them in the garden. And I did. So I thought you guys should see what happened to the pinto beans that we planted in class as we were learning about the tundra. Okay, so follow me to my garden. Come on. This is a hammock stand. It's really fun. Okay, so here is our garden. And we planted these pinto beans. And these are all the pinto beans you planted. And look at these beautiful little white flowers that they make, right? See the little white flower? And then what happens, let's see if we can find it. What happens is, okay, so then that white flower, oh here, this is perfect. That white flower gets pollinated and it starts to grow a pinto bean pod, right? You see that? And then it keeps growing, and then it keeps growing, and then it ends up looking like this. And this one, I mean, you can, 1, 2, 3, 4, 5. There's 5 pinto beans in there. And when this turns yellow, we'll take it off, we'll pop it open, and we'll have pinto beans. I can let them dry, and we'll have pinto beans. Let me look in here, see. Oh yeah, see, look right in here. My sweet son has been coming out here and counting how many pods, wondering if we'll have enough to have like a whole meal or not. These grow really easily, but you know, I'll be honest with you, pinto beans are cheap. You can buy a whole bag for $1. And so, you know, they're fun to grow, but it's not like, yeah, see, look how long this one is. But it's not like I'm saving a lot of money growing my own pinto beans, you know? See that one? Let me see. 1, 2, 3, 4. I bet we'll get about 5 in each one. So my son came out here and he counted all the pods, and then he multiplied it all by 5, and he thinks we'll have enough for a meal. It'll be fun. So yeah, so those are the pinto beans. I wanted you guys to have a chance to see them. So let's go and check on our cups and see what works better, if the paper works better or the aluminum foil works better. So come on, let's go back inside the house. And I'm going to use a thermometer. Now, it's okay if you don't have a thermometer. really, you can just test to see if it's still warm or not. So, here's my thermometer. Let's go outside. And I'm just gonna stab it straight through the plastic wrap. Let's see. And then let me get the other thermometer from outside. I'll be right back. Let me grab that, and then I will stab that straight in. I will tell you that this feels hot from it. So that's interesting to me, and it makes me wonder if more heat escaped because the metal's a conductor. Let's see. And I'm right. So if you look here, the one with the metal, what does that say? 48? How's it looking? It's just letting me hold it straight up. Does that help? No. Let me turn it like that. Is that better? So what do we have? 40, 50, 51, 51 degrees Celsius, 52 degrees, 52 degrees Celsius, 51 degrees Celsius. Okay, and let's look at this one. They're very close. What does that one say? $51? 50. Okay, so we have 52 degrees Celsius and 50 degrees Celsius. So very close, right? We did some good insulating, but we did find that the metal is a better insulator than paper. That's very interesting. We were in New York City exactly 1 month ago today. 1 year ago today. And exactly 1 year ago today, we got coffee from one of these little trucks, because that's where you buy food in New York City. It feels so weird. I like to go to the grocery store. So we bought some coffee off of one of these trucks, and it came in this Greek looking cup, which was kind of fun. And the cup was scalding hot because it was made out of paper. If you've ever gone to Starbucks, they'll give you the little cardboard thing to put around your coffee cup, and that's so that you don't burn your hands. Paper is not a good insulator. Interesting, fascinating. Interesting. Isn't science fun? Okay, so test and evaluate here. And so we did. I'm gonna put on here, because I didn't really show it very well. I could not fit all these little tiny balls. And then I had some in the back too, right? Because it's 3D, so there's one in the front too. And then improve, well, I think the metal is better. The metal won for sure. And I would be interested to see if we did wrap around the cup and then did the balls, if that would help. Interesting. Okay, boys and girls, I have one last thing for you today, and that is our story. I'm gonna move this to the side. I'm gonna move this to the side. I'm gonna move all of this. Clear my space. And I have a book for you. It's The Magic School Bus, Inside the Earth. Why would we be reading a book about inside the earth? Well, we've been talking about earth, thermal, heat. So earth heat, geothermal energy, and we've been learning about how the water that gets heated in the earth comes up as steam. And so let's talk about the inside of the earth. Let's learn a little bit about what's going on inside of the earth as we learn about geothermal energy. Now, Magic School Bus is fun because it's fun to read on your own, because there's like the story, And then there's like all these other little things that are happening all over. So it's just kind of fun to look and everything. I'm gonna just read the story. I'm gonna just read the story part of it, okay? But these are always fun to get from the library when the library reopens, and then you can look at it that way. How are we going, Mr. Sylvie? Am I in a good spot for the camera? What do we think? Yes? All right, here we go. In Miss Frizzle's class, we had been learning about animal homes for almost a month. We were pretty tired of it, so everyone was happy when Miss Frizzle announced, "Today we start something new." Look at her with her dinosaur dress. And look at the beaver. Okay. "We are going to study about our Earth," said Miss Frizzle. She put us to work, writing reports about Earth science. "And for homework," she said, "each person must find a rock and bring it to school." But the next day, almost everyone had some excuse. And 4 people had done the homework, and Phil was the only one who had found a real rock. "I guess we'll have to go on a field trip and collect rocks," said Miss Frizzle. You never know what will happen on a trip with Miss Frizzle. Her new dress was a trip in itself. At first, the old school bus wouldn't start, but finally we were on our way. Look at shovels, picks. When we came to the field, all the kids wanted to get out of the bus, but suddenly the bus began to spin like a top. That sort of thing doesn't happen on most class trips. It does if you're in the Magic School Bus. When the spinning finally stopped, some things had changed. We all had on new clothes. The bus had turned into a steam shovel, and there were shovels and picks for every kid in the class. "Start digging," yelled Miss Frizzle, and we began making a huge hole right in the middle of the field. Before long, clunk, we hit rock. The Frizz handed out jackhammers. We began to break through the hard rock. "Hey, these rocks have stripes," said a kid. Miss Frizzle explained that each stripe was a different kind of rock. We chipped off pieces of the rocks for our class rock collection. "These rocks are called sedimentary rocks, class," said Miss Frizzle. "They are often fossils in sedimentary rocks." Wouldn't you know it, just when we were finding lots of fossils, Miss Frizzle said, "Back on the bus, kids." Then, as we were driving along, we heard rock crumbling underneath us. Down we went. Everything was pitch black, and we were falling, falling, falling. We landed with a bump. Miss Frizzle switched on the headlights. We had fallen through a hole into a huge limestone cave. "Rainwater has been dripping down through the earth for ages," said Miss Frizzle. "The water wore away this cave in the rock." We wanted to stay for a while, but suddenly the bus sprouted a drill. It started boring through the rock. Frizzle shouted, "Follow that bus!" And down we went. The further down we went, the hotter it got. Remember geothermal? The rocks were harder too. "These are rocks that were changed from one kind to another kind by heat and pressure," explained the Frizz. "Rocks that were changed are called metamorphic rock." We went down even farther toward the center of the earth. We hit rock that was formed a long time ago from a pool of melted rock under the earth's surface. Rock like this is called igneous rock. We had dug all the way through the earth's crust. It was so hot now that Miss Frizzle told us to get back in the bus. She stepped on the gas, and suddenly the bus started really drilling. Soon we were actually inside the earth. It was hot, 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 and it got hotter and hotter as we zoomed toward the center. Geothermal. We were glad when Miss Frizzle headed out again. We reached the Earth's crust and drove straight up through a tunnel of black rock. It was great to see the sky. Oh, phew, they made it out. Then we looked around. We had come out on an island in the middle of the ocean. Isn't this wonderful, class? Said Frizzy. We've driven right up on a volcanic island. It didn't look like much, but if Miss Frizzle was right, the whole island was one big volcano. We were nervous, but Miss Frizzle made us collect some rocks. She said they had all hardened from the melted rock that had come out of the volcano. Then, suddenly, we heard rumblings from below. We scrambled into the bus. The Frizz turned the ignition key and stepped on the gas. Nothing happened. The bus would not start. We thought we were goners. Red hot lava came streaming out of the volcano. Some of it shot into the air like a fountain. Some of it flowed over the land like a river. Our bus went right along with it, right toward the sea. This is dangerous, boys and girls. Don't ever do this, okay? You would not be okay. When the red hot lava hit the water, it made a huge cloud of steam. Shh! All we could see was white. We seemed to be rising with the steam and floating along. No one knows how long we floated in the cloud. But when it finally cleared, we were back in the school parking lot. This is really neat because it names all the different types of rock that are just there at the school. It had been a weird trip, but we did get a great rock collection for our classroom. These are all the different rocks they collected. And that's the end. Now, boys and girls, I do want to let you know that nobody has ever seen the center of the Earth, but scientists have made guesses about what is there based on the information that we do have. So nobody's driven a bus to the center of the Earth and then came out a volcano. This never happened. So just wanted to end with your homework for the week. It's this page here. It's called Converting Energy to Motion, and we learned a little bit about how geothermal energy is converted into motion. So you have this page, and just go ahead and read this topic here and then answer these questions here, okay? So that is your homework for the week. I hope you guys have I feel like I have compost all over me. Ooh. Okay, I hope you guys have a wonderful week, and I hope to see you guys very soon. Bye.